Hey, I'm Mitchell and welcome to another video in the RSP education series. Ever wonder why a single-phase motor doesn't just start spinning on its own? You turn it on and without the right components, it just hums, doing nothing. That's because single-phase power has a major flaw. It can't create naturally rotating magnetic field. But don't worry, that's where split-phase windings and capacitors come in. These clever engineering tricks turn a single-phase motor from dead weight into a powerful rotating machine. In this video, we're breaking down exactly how it works. What's phase shift? How do split-phase windings and capacitors create enough torque to get things moving? Why do some motors need a capacitor while others don't? If you want to truly understand how single-phase motors overcome their biggest weakness, stick around, because once you get this, you'll never look at motors the same way again. If you like this kind of content and want more educational videos like this, please like and subscribe. Also, this video is for educational purposes only. Always consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. Let's talk split-phase windings. So the motor has two sets of windings. One is the main or the run windings, and a secondary winding called a start winding. The start winding helps create a phase shift to start the motor. It's designed to make the current slightly out of sync with the main winding. This small difference creates a push that starts the motor spinning. Phase shift refers to when the start winding is connected in parallel with the main winding, but has a higher resistance and lower inductance. Having higher resistance means the start winding limits the flow of electricity more compared to the main winding, and this helps create a delay in the current flow. Having lower inductance means the start winding doesn't resist changes in the current as much, and this allows it to respond a lot more quickly when the motor starts. Higher resistance and lower inductance overall means that the start winding reacts faster to voltage changes. The main winding with lower resistance and higher inductance delays the current flow more, and this causes the start winding current to reach its peak slightly earlier. Together, these properties create a time difference between the two windings, or a phase shift. And this generates a rotating magnetic field that helps the motor start smoothly. This causes the current in the start winding to lead the current in the main winding, and this creates that phase shift. The phase shift generates a weak rotating magnetic field, but still enough to start the motor. So let's talk now the start mechanism disconnect. So once the motor reaches about 75 to 80% of its full speed, there's a centrifugal switch or relay that disconnects the start winding, and this leaves only the main winding to keep the motor running. So why it's needed? Split phase windings, without them, having just a single phase motor, it would just hum and not start because single phase power alone produces only an oscillating, we talked about this last video, back and forth in a line, not rotating magnetic field. The phase shift from the start winding helps create a small rotational force or torque to get the motor spinning. Capacitors start single-phase motors. So a capacitor start motor is a type of single-phase induction motor, and it uses a capacitor to improve the starting torque. So it's the same as the first example that we gave, except a capacitor is added to the start winding to make the current even more out of sync. It's commonly used in applications that require high starting torque, like compressors, pumps, conveyors, large fans, blowers, etc. The start capacitor, the way this motor works, the start capacitor is connected in series with the start winding. The capacitor creates a greater phase shift between the currents in the start and main windings, and this results in a stronger rotating magnetic field. This provides higher starting torque than a standard split-phase motor. Remember, both of these are split-phase motors. It's just that in one motor that requires more torque, that's when the capacitor is added to the start winding. Then comes in the centrifugal switch or relay that we just discussed. Once that motor reaches about 75 to 80% full speed, like we said, that centrifugal switch or potential relay disconnects the start winding and capacitor. The motor then runs on the main winding alone, just to review. So the result is by using either split phase windings and or capacitors, the motor creates a rotating magnetic field that makes the motor spin that it couldn't accomplish on its own. So now you know why single phase motors don't just start spinning on their own, how they overcome that limitation with split phase windings and capacitors. By creating a phase shift, these components generate just enough torque to get the motor moving, and that phase shift is a difference in current reactivity like we were discussing. Whether through simple winding arrangements or with the extra boost of a start capacitor, we discussed how these single phase motors are going to get spinning. Once the motor's up to speed, the start mechanism disengages, and that leaves the main winding to keep things running smoothly. But here's the big picture. While single-phase motors can be incredibly useful, they do come with limitations, especially when it comes to power efficiency, starting torque, and even handling heavy loads. That's where three-phase power changes the game. In the next video, we're going to dive deeper into the world of three-phase power. We'll break down why it's more efficient, how it delivers constant power flow, and why it's the backbone of industrial automation. If you're serious about understanding how industrial motors work and why three-phase is the gold standard for high-power applications, you don't want to miss it. See you in part 3. For hundreds, as always, of thousands of other industrial automation products, please go to our website. And for any other information or more educational videos, go to our website, rspsupply.com, the internet's top source for industrial hardware.